Hello everyone, this is Sai Sri and welcome to my channel. In this video, I will tell you how to answer an important 8-mark question from oscillations. In oscillations, we have two important 8-mark questions. One is simple harmonic and the other one is simple pendulum. Simple harmonic question may be asked like, define simple harmonic motion, show that the motion of projection of a particle performing uniform circular motion on any diameter is simple harmonic. To answer this, first of all we have to define the simple harmonic motion. This question is very important because also for 18 and 19 for AP. First of all we have to write the definition of simple harmonic motion. The definition is, a body is said to be in simple harmonic motion if the acceleration is directly proportional to the displacement from the fixed point and it is directed towards the fixed point in its path. So, this means that acceleration is directly proportional to displacement but in opposite direction. Here minus indicates that it is in opposite direction. A is acceleration, x is displacement. We can also write this proportionality as minus omega square. A is equal to minus omega square y. First of all, we have to define what is meant by projection. Projection is a point on y-axis that the particle in circular motion by a perpendicular line at projection angle 90. So, here the projection is at C, 90 degrees. We have to prove that C is a projection is in simple harmonic motion. The particle C, which is oscillating on the foot y-axis, is in simple harmonic motion. So, first of all, to write the expression, consider a particle P. It is the particle which is moving on the circumference of the circle. So, it is moving on the circumference of the circle of radius r, and the radius of the circle is r, and theta at a given time t. So here theta is equal to omega t. Omega is angular velocity at a given time t. So theta value is omega t, which is useful in deriving the simple harmonic equation. And also x dash and x are two mutually perpendicular diameters of a circle. And here y is the displacement. And this C oscillates in the sense to and fro motion. So C moves on the perpendicular foot of y-axis. Let the angular displacement be y, and x dash, x and y dash are two mutually perpendicular diameters of a circle. And C moves on the diameter yy about O. So its perpendicular foot oscillate in y-axis, which I have explained before. First of all, we have to find the displacement of the projection. To find displacement, I am taking sin theta. Sin theta is nothing but opposite by hypotenuse. From the diagram, P is the particle, O is the origin, C is the point in which it oscillates in y-axis. I have taken the displacement as y and the radius is r. So, theta, opposite side is y and the hypotenuse is r. I have substituted the values here and we know that theta is equal to omega t. So, in place of theta, we write omega t is equal to y by r. From this, r will go this side and it will multiply. Y is equal to r sin omega t. This is equation number 1. And the velocity. Here the velocity is nothing but displacement by time. Displacement. d by dt is y. Here displacement is y. We know that y is equal to r sin omega t. So v is equal to r omega cos omega t. And the acceleration is, here the acceleration a is equal to differentiating the velocity at the rate of change of time. Here v is r omega cos omega t. So here we have to differentiate. minus r omega square sin omega t. We know that y is equal to r sin omega t. So in place of r sin omega t, I am writing y minus omega square y. So we got the equations. A is equal to minus omega square y, which is directly proportional to minus y, the displacement. At the end, we have to write the acceleration of P is directly proportional to the magnitude of the displacement, but in opposite direction. Why opposite direction means? Here we got A is directly proportional to minus y. Minus y indicates that in opposite direction and always directed towards the fixed point O in its path. The above equation represents simple harmonic motion. What is above equation? It is A is directly proportional to minus y, or A is equal to minus omega square y. Represents simple harmonic motion. So the projection of particle is in circulatory motion.